So we're going to work on the warm-up. This is just reviewing solving by square roots, which we talked about yesterday. Take a few minutes, go ahead, try the warm-up, and then we'll go over it together. So the first thing I would do in the first problem is add the 13 to each side, and that would leave me with 4b squared equaling 16. Divide each side by 4, and you get b squared equaling 4. When you square root each side, you get b equaling positive negative 2. Number 2, I'm going to divide each side by 9. That gets me 25 over 9. Because these are both perfect squares, when I square root it, x will equal positive or negative 5/3. This last one, I'm going to add positive 18 to each side, so that's going to give me 3n squared equaling 30. I'm going to divide each side by 3, so n squared will equal 10. I'm going to square root each side, and n equals positive negative 3.2. Today we're going to look at a different method of solving by solving quadratics. This method is known as completing the square. It is a 4-step process until we actually get down to solving it. You'll notice as we go through all of these different methods that certain problems lend themselves very nicely to certain methods. Such as if I'm dealing with an equation that's basically made up of perfect squares, I'm probably going to use square roots because it would be fairly easy. So, to complete the square, when we complete the square, we are not given a c value. So we have ax squared plus bx equaling something. Okay? This is one of the few problems that we solve quadratics with where we do not make the other side equal to 0. Okay? We actually leave it as ax squared plus bx. So the first thing we're going to do is we're going to take b, we're going to divide it by 2. So whatever the coefficient of x is, we're going to take that number, divide it by 2. Then we're going to square whatever we get after we divide it by 2. We're going to plug that in as our new c value. And then we actually rewrite it as the square of a binomial. We actually break it down into parentheses. So let's go ahead. We'll get started so you can see what these steps actually look like as well. So at this point, we're just going to start with the basics. We're not actually going to solve anything yet. We're looking to figure out what c is. So we have a being 1. We have b equaling 5. We take b, we divide it by 2. And then we square that result, which would be 25 over 4. This becomes my c value. So at this point, I have x squared plus 5x equaling, or not equaling, plus 25 over 4. Now it asked us to write it as the square of a binomial. So that's going to be a parentheses. The square root of x is x. The square root of 25 over 4 is 5/2. And the reason we go through this process of what is known as completing the square is that we can take the square root easily in order to be able to write it as the square of a binomial. You might notice that the second part in the parenthesis is usually your b value before we square it. There is a purpose to squaring it when we actually get to solving equations. So we do want to get in the habit of taking b, dividing it by 2, and squaring it, then breaking it down to the square of the binomial. And again, this parenthesis is what is referred to as the square of the binomial. I'm actually going to walk through all of them with you, but I'm going to walk through problem number 2 and then give you a few minutes to try the others on your own. So in number 2, I'm going to take b, I'm going to divide it by 2, which would give me 4, and I'm going to square 4, which gives me 16. So that gives me a new trinomial of x squared plus 8x plus 16. I need to break that down to the square of a binomial. X squared, the square root of x squared is x, the square root of 16 is 4, and that is the square of my binomial. In number 3, you can go ahead and try them on your own if you want. In number 3, I'm going to take negative 12, I'm going to divide it by 2, that gets me negative 6. Please be careful, when we square negative 6, you should get positive 36. Now when I break this down into my square of the binomial, square root of x squared is x, square root of 36 is 6. Because my middle term was negative, it needs to be negative in my parenthesis. Okay, think about if we were to actually FOIL that out. X minus 6 times x minus 6. We would have to have the negative inside the parenthesis in order to get that middle term, or our b value, to be negative. Number 3, I'm going to divide 3, possibly, if my pen will work. I'm going to divide 3 by 2. I'm going to square that. When I square that, it becomes my c value, and my c value becomes 9 over 4. Breaking it down to the square of a binomial, you have x plus 3 over 2. This time it's plus or addition because my middle term was addition. The middle term is going to indicate what your sign would be in the square of the binomial. Number 5, 7 divided by 2. So that's going to give me x squared plus 7x. When I square 7 over 2, I get 49 over 4. The binomial would be x plus 7 over 2 squared. So far, all we've done is find c. We haven't actually solved anything. We've just been rewriting the problems. Now we're actually going to look at solving. When we solve with completing the square, as I mentioned earlier, we do not want to have a c value on the left-hand side. So on the left-hand side, all we want is our a term and our b term. Any constant we want over by itself on the right-hand side. And the reason being is by doing that, we can actually get a c value by dividing b by 2 and squaring it. And it'll actually end up giving us nice squares of binomials, nice parentheses to then work with. So off we go. First thing I'm going to do is I'm going to take a b, which is negative 16. I'm going to divide it by 2, which is negative 8. I'm going to square that, and I get 64. So just like before, 64 is going to be our c value. So x squared minus 16x plus 64. This time we have an equation. And if you remember, one of the big rules of equations is whatever I do to one side, I have to do to the other. So if I'm going to add 64 to the left-hand side to get my trinomial, I also have to add 64 to the right-hand side. And this is why it's important that we actually square it, because that squared value is what has to be added to each side. My left-hand side is going to break down into x minus 8 squared. Negative 15 plus 64 is going to give me 49. I'm going to square root each side. So x minus, this is going to look very much like our square root problems at this point. So x minus 8 equals positive negative 7, because the square root of 49 is a perfect square. So I'm going to add 8 to each side. So we're going to end up with x equaling, I've got to get back to my pen, 7 plus 8, and x equaling negative 7 plus 8, or 8 minus 7, however you want to look at it. So my two answers are going to be 15 or 1. And again, you can check these. You would need to check each answer individually in the problem itself. So you would do 15 squared minus 16 times 15 and hope that you end up with negative 15 on the left-hand side. So I have 4 of these for you to try. I'm going to walk through number 2 step by step again so you can see it. And then I'll just go over the answers for 3 through 5. And if you have any individual questions on 3 through 5, you can certainly ask me. But the process is not going to change for any of these problems. So in number 2, I'm going to take b. I'm going to divide it by 2, which is 3. I'm going to take the 3 and square it, which gets me 9. That 9 is going to be added to both sides of my equation. So x squared plus 6x plus 9 will equal 7 plus 9. My left-hand side is going to break down to x plus 3 squared. And on the right-hand side, I'm going to end up with 16. Square root each side. X plus 3 equals positive negative 4. Subtract 3 from each side. So x equals negative 3 plus 4, which is 1. Or x equals positive 3 plus 4, which equals 7. So my two answers would be 7 and 1. For number 3, if you've taken some time and you've solved them, number 3 should be negative 1 or 3. Number 4, you would get decimals. You would just round off to the tens place. I have negative 9.1 or negative 0.9, negative 0.9. And for the last one, I ended up with 14.7 or negative 0.75. Please be careful when you're writing your answers in parentheses like I did for those last 3. Please make sure you are using the word or and not using a comma, because these are not, these are not ordered pairs. Okay, so we don't want to make the mistake of having them represent an x or a y value. Homework tonight, again, we don't have a workbook, so it would be a worksheet, and you should have it in front of you. If you don't, you can always find it from my website, and we'll go from there. So now we're on day 2, so we're going to go ahead and start with our warm-up. It's the same thing we were finishing up with yesterday. So I'm going to take the 2x, possibly. I'm going to divide it by 2, that gets me 1. I'm going to square 1, that gets me 1. I'm going to add 1 to each side of the problem. So x squared plus 2x plus 1 equals 3 plus 1. My binomial breaks down into x plus 1 squared equaling 4. Square root each side. X plus 1 equals positive negative 2. Subtract 1 from each side. And x will equal 2 minus 1 is 1. Negative 2 minus 1 is negative 3. For number 2, I ended up with negative 12 or 2, and for the last one I ended up with negative 1 or 15. Does not matter if you have 15 or negative 1 and then 15, as long as you have both of them there. The only difference between what we did yesterday and what we did today is you'll notice that this equation is set equal to 0. So in order to solve by completing the square, we're actually going to move the negative 8 over to the right-hand side by adding positive 8. This is a good problem to solve by completing the square because b is even. Okay, which means I can divide it easily by 2 and not work with nasty fractions. So traditionally, we use completing the square only if b is even. So first thing I'm going to do is move the negative 8 over by adding positive 8. So 2x squared plus 20x will equal positive 8. I'm going to take b, I'm going to divide it by 2, I get 10. I'm going to square 10, which is 100. I'm going to add 100 to each side of the equation. Actually, I'm going to erase this whole thing because I forgot something we needed to do at the beginning. You guys can't talk back to me, but if you take a minute, think about what I might have wanted to do at the beginning before I started anything. If you haven't picked up on it, please notice that all 3 pieces of this problem actually have a GCF. I can actually divide all of them by 2, which is what I'm going to do. basically going to simplify the equation. We always want it to be x squared out in front. We don't want to have a coefficient in front of our a other than 1. So we're actually going to be working with the equation x squared plus 10x minus 4 equaling 0. So now I'm going to add 4 to each side. So x squared plus 10x equals 4. Divide by 2, I get 5. Square it, I get 25. And we're going to add 25 to each side of the problem. So x squared plus 10x plus 25 equals 29. 4 plus 25 is 29. My right-hand side is going to break down into x plus 5 squared equaling 29. Square root each side. X plus 5 equals positive negative square root 29. Don't take the square root of 29 yet. It will give you a decimal. Wait until we actually get down to the end of the problem. So I'm going to subtract 5 from each side. So x is going to be negative 5 plus the square root of 29, which would be the 0.39 or 0.4 depending on how you rounded it. Or x equals negative 5 minus the square root of 29, and in this case we would have negative 10.4. Basically, I just want you to try these 4 on your own. See how it goes. Nope. I'm having issues with the screen. You'll notice that they all have a coefficient. You want to go ahead and get rid of that coefficient. So in the first one, I'm going to divide everything by 3 before I start. So in number 3, I ended up with 1.2 or 5.2. I know my handwriting's getting worse the longer I do this. So 1.4 or 6.7 for number 4. 5 is negative 2 and 1. And the last one is negative. Nope, I didn't want to do it. Negative 3.7 or negative 0.3. And that's it. Your homework tonight is a worksheet. You're going to be working on 13 to 27 all. If you have any individual questions, as always, you are more than welcome to come and speak with me. If you do not have the worksheet in front of you, you should be able to find it from the team calendar and or from my individual website.